Hi everyone, welcome to Data Science with Taif Najib. In today's tutorial, we are going to build a project called Customer Churn Prediction, where we are going to build a model that will predict whether a customer will stay or churn. So for this project, we're going to use a Kaggle dataset posted by Mustafa Bataun Hermes. And as you can see, the dataset has one CSV file called data1.csv, and this CSV file has 20 columns. We're gonna need some of the columns, and we're gonna get rid of some of them. So let's get to the project. Before we start, let me tell you, this project will use XGBoost as our classification algorithm. So let's give it a nice title first. Customer Churn Prediction using XGBoost. Okay, let's make it bold and try to make it bigger. So first things first, we're going to import the dependencies. The first one we're gonna need is Pandas, of course, and then we also need NumPy. As I said before, we'll need XGBoost, so let's import that as well. XGB. We're also going to need some of the scikit-learn's features or tools. Let's first import scikit-learn model selection, import train test split. Also, we're gonna use a normalizer, we also need grid search CV, so let's import it as well. So that's it, I guess. So let's run this. Oh, sorry, there was a typo. Now let's run this. To avoid all the warning, I'm going to import warning as well. Warnings, and let's run this as well. We need to upload the dataset that I previously downloaded. Let's drop it down in our file section. As you can see, it's there. We don't need to see this. Let's get it outside our view. So let's we're gonna create a data frame first. df pd dot read underscore csv. We're gonna give the name csv, and when we are done, we're gonna run this cell. Sorry. Okay. There is a problem with the CSV file. I have checked it using a text editor that it is not separated by comma. Actually, it's separated by semicolon. So we're going to use a sep argument. Let's see. Yes, it's there. So we're going to see the first 5 rows of our data frame df. As you can see, all the columns are here, and there are a lot of things we need to do. So let's do some investigation about our data frame. Let's see the shape of our data. As you can see, there are 3,333 rows and 20 columns. Also, let's dig down a little bit more and see some other information. So as you can see, there is actually no null values. Everything is non-null, and the data types are, we need to work on that. We need to change some data types. So let's start working. As you can see, there is one column called location code, and it's an integer. We don't want that. We need to change it to object, because location code normally is just like postcode, and this 415 has no numerical value. It is actually a categorical value. So let's handle our location code column. So df location code, and we need to check whether how many values that we have, like unique values. So as you can see, here we have 415, 408 and 510. These are the unique values that we have. So we can easily turn them into objects, and turn them into categorical values and handle it accordingly. So for this, we're going to use location code is equal to location code dot so we're going to turn this into a string. So let's see. Yeah. After that, if we just take a look at the credit card info save, this looks like an object, like a string value, and if we just check it from here, yeah, it is just yes, no. So there are two things we can do. It is the same for the push status as well. So yes, no. The first option is we can treat it like a categorical value, just like location code, and then get dummies and do all kinds of maybe one hot encoding or something like that. But we can also turn the no as 0 as an integer and yes as 1 as an integer. That way it will turn into an numerical column. So let's do that. So we're gonna credit card info save. So this one, let's just do a quick investigation about our unique values. Yes, it's yes or no. There's nothing more. There could be one value called maybe or something like that, but we only have yes and no, so we can easily turn it into 1 and 0. So let's do that. I'm gonna copy that. And I'm going to use replace. So for every yes, I'm going to use 1, and every no, I'm going to use 0. So I'm going to do the same thing for the push message column as well. So let's copy the push status. Let's copy the column name and then paste it here. So I think we are good to go. And also, as you can see, here we have some columns such as average order value, and also discount rate per visited product, and also product detail view per app, add to cart per session. So these values are mostly objects, and they have commas in it. So I think that's an error, because we have to turn it into a float value. We should replace the comma with dots so that it makes sense. So let's do that. Average order value, we're gonna copy it and paste it again. So we're going to use .str dot replace, and then comma with dot. That's what we should do. And also we're going to change the type to float. Let's also try the same for other columns. We have 4 columns. We should be good to go. Yes. Now we are going to get one hot encoding. Now we are going to treat the categorical value location code, right? So this one, as we already turned it into an object, a string value. So now we are going to handle our categorical value for the location code, right? So let's do that now. So tf is equal to pd get dummies tf and columns is equal to we're gonna use location code, right? It's done. And now let's drop the unnecessary column user ID. For classification problem, we don't need user ID for now, because there are a lot of unique values. It means nothing to us. df is equal to df dot drop user ID. Did I write the column name correctly? Yes. And then we need to set the axis at 1. that should be it. After all the pre-processing, let's just check the data frame if it is just the way we want it. Yeah, as you can see, the categorical values are handled nicely, and there is also this churn column. We didn't do anything with it. One more thing, we need to scale the data, because as you can see, there are different types of values right here. Many of them are float and many of them are integers, but because of the different sizes of the numbers, is going to affect our model negatively. So let's scale it. And as you know, we already imported normalizer. So before we do that, we need to check which columns we're going to use the normalizer for. So let's do one thing. We're gonna use all the columns and see the column names. Here we're gonna copy that. We copy all of it, and now let's create our calls to scale. I'm going to use everything. So we'll keep account length, of course, and we'll get rid of credit card info save and push status, because those are just 1 and 0, and if you normalize 1 and 0, it is useless. So add to wish list, yes. Desktop session, why not? We're gonna also get rid of this 3 column names from here, and also we'll get rid of churn. Let's see if we have anything else. Yeah, that should be it. We're going to use normalizer as our scaler, normalizer, and we're going to fit transform. Maybe use scale data, and then text scalar dot fit transform. We're gonna use df, and then only the columns to scale. And then when we do that, when we use normalizer, normally it returns NumPy's ND array. We don't want that. We need to turn it into a Pandas data frame for our convenience. So let's just do that. Scale df is equal to pd dot data frame. So let's put scale data, and the index will be the same as df's indexes, and the column names will be the same as the list called calls to scale. And let's do that. There's a typo right here, so we're gonna have to make it capital. Let's try this now. Yes. So now we have a data frame called scale df, right? And if we just take a look at the first 5 rows, we're gonna see it has all the columns that were included in the calls to scale list, right? We're going to merge this scale df with our original data frame, but before that I'm going to drop the columns to avoid duplication. Calls to scale, sorry, then gonna set the axis as 1. Let's now merge them. Pandas dot merge df scale df left index is true and right index is also true. Let's do that. And after that we're gonna divide our data set into train data and test data. For this, let's just add a comment right here. Let's split. Let's define our x, which is data frame minus the churn column. We have to set the axis again, and our y is data frame and only the churn column, because that's what we're going to predict, right? And after that we need to define x train, x test, y train and y test, and we'll use train test split that we already imported in the first portion of the video. So let's do that, but we need to add x and y along with the test size, which I believe would be 33%. You can use anything, you can use 25, you can use 20, you can use 30, but for this project I'm just randomly using 33. And we're gonna add a random state as well. Okay, so let's do that. No error, we are good to proceed. Let's print the size of x train dot shape, x train x test dot shape, y train dot shape, and y test dot shape. Let's do that. As you can see, it is already split, it's divided. Now it's time for us to build the model, and let's add a comment first. We're going to use XGB underscore CL, that is classification, is equal to before, earlier we imported XGBoost as XGB, right? So XGB dot XGB classifier and we're going to fit this model. So fit with X train and Y train, right? So let's do that. Now we're going to predict we're gonna predict our X test, predict our Y test from our X test data frame using the same model. X test. Nice. And if we want to check the accuracy of our accuracy score of our model, we can do that. Y test and the preds. Oh, we forgot to import the accuracy score, so let's do that. From scikit-learn dot metrics import accuracy score. Right, so let's run this, and now it will be all fine. So let's print our accuracy score. Model accuracy for test data set. Let's run that. Yeah, as you can see, it's 91%, 91.54%. We are going to use hyperparameter tuning for this. Let's see how much better we can make in just one go. For this one, let's add a comment first. We are going to need our parameter grid, which is param grid, and we can turn it into a dictionary where max depth is maybe 5, then learning rate is maybe 0, 0.01, 0.05, 0.1. Then we can also use gamma, and we can try 1, 5, 10. Let's try that. And also there are other parameters as well, for example scale, pause, weight. Let's try that. Sorry, scale underscore pause weight. Well, we can try maybe 2, 5, 10, and even maybe 20, and we'll use subsample. We'll just keep it 1, and another one we'll use call sample by tree. So call sample, then underscore by tree. Let's just make it 1. After that, we're gonna initiate the classifier, which is XGB underscore CL2, and that one is XGB dot XGB classifier, and then we can use objective binary logistic. Let's make it 3. Scoring is ROC underscore AUC. And we're gonna feed that, and for this we will use grid the score is slightly lower than what we had before, but that doesn't matter because we're going to use it on our test data set and see if it is improved or not. So final model is final underscore CL xgb dot xgb classifier best params objective binary logistic. So that's what it is, and let's feed this create underscore final is equal to final underscore cl dot fit x train y train. Let's predict the y test on the x test dataset. Create underscore final dot predict x underscore test x underscore test. So let's see the accuracy now. Accuracy underscore score y test and preds. Let's print the accuracy score, accuracy of the final model. Let's do this. Yeah, it's slightly improved. So as you can see, by hyperparameter tuning you can improve the model, and also if you test with different feature engineering, different pre-processing technique, the model's accuracy will increase over time. 92.72% is already not bad, it's good. So let's just stop right here. Thank you very much.